Very good evening to all. Is my voice is clear? Can anyone respond in chat box? I'm audible to you. So very good evening to all. So good evening, Ankit, Manoj, good evening. Venkat, good evening. So Narayanamurthy, very good evening. Thank you for your joining. So is my voice is clear now? Can anyone respond in chat box? Just put yes in chat box. Is my voice is clear? Yeah. Kannan, very good evening. Thank you for joining. Venkat, hi dear. Yeah, okay. Yes, I'm audible. Will associate you to your. So yes. Thank you for your joining. So today we are gonna see a combinational circuits and the digital circuits. So combinational circuit and sequential circuits. So these are the basic skills or basic knowledge as you need a VLSI engineer. Okay. So I'm audible. Yeah, thank you for your response, Bharat Raj Singh. Manoj, thank you. So directly we'll go into session. Yesterday also last Saturday, I asked one question, how sound system work. So it is based on the decoder logic. So it comes under the combinational circuits. So mainly as a VLSI engineer, as a design engineer, if you are making the chip means you are writing Verilog code or design code based on the circuits only. It may be combinational, it may be sequential circuits. If your logic is based on the clock means you are writing the sequential logic. Okay. As well as if you are writing sequential logics, there is a part also combinational logic. So combination of sequential and the combinational logic only, we can write the logic in system near Verilog design code. So design code is nothing but functionalities of chip. So if you are making the one chip, so you are writing the very basic thing about the chip, like a logic. So what is the logic of this, or what is the work of the chip? So you are writing the functionalities of chip by using Verilog code. Okay, this is a design code. So if you want to you are a design engineer means you have to must aware and you have to throw in digital electronics. Okay, actually we seen K-map, Boolean algebra, and then number systems. So number system also very important. While entering into memory part, the number system plays vital role. Okay, so today we are going to see combination logic, combination circuits, like a full adder, half adder, encoder, decoder, mux, demux. So what are the usage of this, how to design by using logic gates, how to design that in combination logic, we will see in this session. And also sequential logic also. Sequential logic means we will see the functionalities of clock. So usage of clock, and then how how the latches and flip-flops differs. So what is the basic difference between latches and flip-flops? So we'll see in the one by session, and then we will see the variety of flip-flops, like a JK flip-flop, D flip-flop, okay, SR flip-flop. So we'll see one by one in this session. So this is for today. So and then let's tomorrow we'll start with the we'll start with skew, like a clocking blocks, like a clock domain crossing, and then delay related things, clock related things, and then how clocks are very important in VLSI field. And then we will see the overview of the system, overview of Verilog. So we will see that tomorrow we will see the introduction and usage of Verilog, and then day after tomorrow we will start with the SystemVerilog. So we are in this master class, we are focusing only verification. So verification means we already have a design code, we have to verify that. For that we have to pass some stimulus to design code. So then only we can verify that our design code is correctly working or not. For that we can use Verilog, but it's very legacy, it is very old trend, so it will take more time to write the test benches in Verilog. So we can use the SystemVerilog and UVM framework to verify the design very easily. And then it is also very useful. Why means it have OOPS concept, so we can reuse the code. This is a main usage of OOPS concept. We can reuse the code, so it is in dynamic in nature, so we can dynamically change, alter, randomize. We will do a lot of things in SystemVerilog OOPS concept. So we'll see one by one in the master class. Okay. So thank you for joining. So very good evening. So okay, thank you Siddharth, Siva, Sandhya. So very good evening to all. Thank you for joining. So we'll see some combinational things. So actually I also asked one question, how sound system works. It is based on the decoder logic only. So we seen Saturday itself. So directly we get into session in the combination logic. Okay. So definition of the combinational circuits. So combinational circuits are digital circuits where the output depends on only the current inputs. So it is not a memory type. It is a combinational circuit. The output of combinational logic is depends on only the current input. Okay. So like a flip flop, if you taken like example as a flip flop means it will need some input as a clock, and then it's like a memory register kind of thing. But the combination logic is not like that. It will, if you given some input means based on your input it will give output. For example, AND gate, so it will continuously assigning the output. So it won't take any delays. It will continuously assigning the outputs. Okay, that's why the it is like a continuous assignment. So while writing the Verilog code, if you are writing the logic for combinational means it will do continuous assignment. Okay, if you write in the Verilog codes, it will easily understand. So it will work continuously. So combinational based on it will work like a continuous thing. So circuits, this is also on circuit. The output is only depends on current input. Okay, not a previous output, previous memory state, not like that. So this is a main difference of main thing of combinational circuits. Okay, let's see the one by one. It having a lot of circuits like a full adder, half adder, MUX, DMUX, encoder, then so on. So it having a lot of things. So let's see one by one. Okay, each and every topic, each and every part of combinational circuits very important, like a full adder, half adder, and then flip flop, D flip flop, sorry, MUX, DMUX, encoder, decoder, and then 4-bit triple carry adder, carry skip adder. There are a lot of logics, and then universal shift register, serial in, parallel out. So this all comes under the combination logic. So you must aware of that. So then only you can write a lot of design logic. You can gain the lot of design logic while writing the design code for your logic. Okay. So do you guys understand definition of combinational circuits? If you understand means just put S in chat box, then only I can move forward. So if you guys really understand, you can really understanding of the combinational logic, you can put S in chat box. Sir, when day 3 and we uploaded in LMS portal, yeah, it will uploading. So now was I think day 2 and 3 I will we are continuously uploading in LMS, so you can watch it. So if you have any doubt means please contact my coordinator. Okay, thank you for your response. Prakash says okay, it sounds like a good, you are following me. Yeah, thank you for Raj Sundar. Thank you for response. So let's see one by one. So we will start with half adder. So it is a basic adder. So it is a basic 2-bit, like a, so it having some inputs having 2 bits, 0 and 1. You can see this 1-bit half adder. So it means it will do one bit. I think it will do 1-bit adder. It means it having 2 inputs A and B, and then can you explain in Tamil language? So Muhammad Tawfiq, if you purchase the like an internship program, we will conduct weekly live sessions. Another time we can communicate with Tamil, but now in the master class, lot of people from north and all over India. So if I speak in Tamil means some people won't understand. So that's why reason I'm speaking English. So in the intent, while if you are purchase the like an internship program, so we have a weekly live sessions. On the time we can communicate in Tamil with preferable language. So just for today. So we'll see the half adder. So it's like a 2-bit like a it having 2 inputs A and B. You can get the sum and carry. It's like a 1-bit half adder. So 2-bit half adder means you can see you can connect it another half adder means it will like a 2-bit half adder. So it having 2 inputs A and B, and then you will get the output as sum and carry. So why so adder means nothing but it will add. So if you like in mathematical 1 plus 1 2 like that, we can do in my binary addition like a 0 plus 0 0, 0 plus 1 1, 1 plus 1 0. So 1 plus 1 it's 2. So 2 in binary means 1 0. So it comes it having 2 bits 1 and 0. So for that on that time we can be having the sum output and also carry output. So we can assign like the of adder having two outputs, sum and carry. So for these three parts, like 1 2 3, 0 plus 0, 0 plus 1, 1 plus 1, it having only sum and carry. So sum 0, carry 0, and then here sum 1 carry 0, here sum 1 carry 0, here also sum 0 carry 1. Why? Because of 2 in decimal 2 we can't represent like in a single bit, so we need 2 bit, at least 2 bit to represent the decimal 2. For that reason I can take 2 bit, like 1 is 0 is sum, and then 1 is carry. Okay, yeah, thank you for our response, Muhammad Tawfiq. So and then let's move into full adder. So full adder means it having the 2 of adder. So like we can add the 3 bits. Okay, like we can add the 3 bits of input. Like for example, you can say here A and B is 1 bit, and then some carry in also on another input. The outputs are sum and carry out. Okay, this is a full adder functionalities. It will add 3 bits. So carry in. So carry is carry in based on the output of previous input. Like for example, here you can see here it having 3 bits. So here I'm having 1, so 1 plus 1, so sum 0 carry 1, same like here. And also 3 bit means it will count up to 8. So here I'm showing only 4. 4 means this is a binary 3. This is a 3 input of 3 binary inputs. If you convert into decimal means it's like a 0 1 2 3. Okay, we can I'm showing that only 3 like a 0 1 2 3 values. If you are writing, if you are in the 3 bit values, we can declare as 0 to 7. 7 means totally 8 values, 0 1 2 3 4 5 6 7. Okay, 7 means in 7 we can declare, we can reference in binary means how we can reference, how we can represent in binary means 1 1 1, 3 bit of 1 1 1. So if you add a 3 bit of 1 1 means what you will get, sum 1 carry also 1. So like this you can see here. So this is the first 4 bit and this is the last 4 bit. So totally 8 inputs. So if you are while dealing with 3 bit means you can count from 0 to 7. Okay, so in 2 bit means you can count only up to 3. So if you want to count more, if you want to deal with more values means you can increase the bit width. Okay, so this is a truth table for full adder. So it have 3 inputs, A and B, and then C in. So these are the outputs, 0 and sum and carry. So you can see here 3 inputs, A1, B1, carry in also 1. So output will be sum 1, carry also 1. Okay, so this is for full adder, and then this is for large bit binary addition. So this is a this is a binary addition, like based on these two rules, like a half adder, full adder, we can do some binary additions. So here this is a you can start from here. This is a bit of A0, B0, it having 2 inputs, A and B. So if you add means you will get the sum 0, and then carry out for another, it's like a full adder. So this is second inputs, A1, B1. So output of this 2 input is sum 0 and then carry out 0. So I am assigning the input as I am assigning the another, like a third input for this full adder. A1, B1, it are already having 2 inputs, and then output of this full adder is I am assigning to my second full adder. So this is how we can do the ripple addition of 3 bits. So we can do ripple addition. Okay, so this is how we can do the binary addition. It's very simple only. So if you guys really understand, you can half adder is 2-bit adder and full adder is 3-bit. Yeah, correctly. So half adder is 2-bit adder, is a 3-bit adder. So and then let's move into subtractor. So binary subtraction. So same like it look, the circuit look like this only. So if you take an half adder means here you can't see this NOT gate, but in subtractor this is a complement of adder, half adder. So it's like a half subtractor. So it will, the circuit look like this only. So it having this output like a subtractant and then borrow out. It having the 2 outputs. It having the 2 inputs A and B, and then outputs are difference and then borrow out. Borrow out means like a carry out itself. So borrow means I will borrow, if for example, if you take in this one like a 0 minus 1, so you can't subtract 0 1 from 0, so you have to borrow from neighbor bit, so that's like a borrow 1. So I can difference is 1, and then but I am borrowing from neighbor bit, so it's like a borrow out 1. So this is a circuit for a binary subtractor of a binary of subtractor. This will look like this only. This is our input and outputs. Here A and B, minute and subtractant 0 0 means we'll get difference as a 0. Then 0 minus 1 is difference is 1, and then borrow also 1. 1 minus 0, so we can comfortably subtract from 1 minus 0. So you will get the difference is 1, and then 1 minus 1. So there is no difference. So output is 0. So here also there is no difference, so again I can get the output as 0 in difference. So this is a basic thing of binary subtractor. So and then we'll move to the this is example how we can do 0 minus 1. You can see here 0 minus 1 we can't subtract 1 from 0, so I have to borrow from neighbor bit. So I'm just here I'm having 1, so I'm borrowing, but I'm doing subtraction here, so I need 1 from neighbor bit, so I'm taking out from here, and then I put here, so 1 0 here. So 2, like 1 0 means 2 only, okay. So 2 minus 1 1, so I will get a 1 as a output. So this is how subtraction will work in binary. So main thing is, if I'm borrowing 1 from neighbor bit means it won't change like a 1 here. It will add a bit like a, for example, if I'm borrowing 1 from a neighbor bit, so 1 0, it will assign like a 1 0, not like a only 1. Why? Because of I'm adding into my current bit, so 1 0 is a correct method to follow the subtraction in binary. So you can't do like a 1 minus 1. No, it's not a correct way. You have to follow, like if you borrow the 1 bit from neighbor bit means you have to use like a 1 0. So you have to add the binary what you are borrowed from neighbor, you have to add from the binary to current value. So if already you having 1 means 1 0 only. If you are already having 1 means you can borrow from binary bit, so 1 1. So this is a step, this is a rule you have to follow in while doing the binary subtraction. Okay. So and then this is a 3-bit binary subtraction. So it's also a very simple one. It having the inputs like A and B, and then B borrow in. So like a full adder itself, it having same thing. So and then you are having the output like a difference and borrow out. So if you know the full adder means it will like a same, like it's like a same thing like a full adder, full subtractor, same input and outputs, but the logic is difference. Okay, it having outputs like difference and borrow out. Okay. So and then we'll do the this is very important circuit, 4-bit adder cum subtractor. So hi sir, so hi, very good evening sir. I think the class goes fastly without understand the concept. So I will explain once again. So I will start from half adder. So half adder means it's like a 2-bit adder. So it can add 2 bits, 2 binary inputs A and B. You will get the output as sum and carry. Okay, this is a half adder. How we can get the sum and carry means, if you add if you add 1 plus 1, so you will get the sum as 1, carry as 0. And if you add the 0 plus 1, you will get the sum as 1, carry as 0. When you are getting sum 0, carry 1 means, if you are adding the both input like having high value. So high value means A equal to 1, B equal to 1. So if you add these both inputs A equal to 1, B equal to 1 means you will get the sum 0, carry 1. Why? Because of 1 plus 1 2. So 2 in binary means 1 0. So you will get the 2-bit of outputs. So we can assign like a 0 as a sum, 1 as a carry. Okay, this is a half adder. So same like here in the full adder. So I will show the full adder. So same like here. So here full adder having the 3 inputs, 2 outputs. So 3 inputs and 2 output means while dealing with 3-bit of adder, while dealing with the 3-bit adder means you having three inputs like a 0 1 0 1 1 1. So there are 8 combinations. 8 combinations is nothing but it will start from 0, it will count, it will start from 0 and it will do up to 8 7. So 3 bit of 0 means 0 0 0, 3 bit of 1 means 0 0 1, 3 bit of 2 means 0 1 0, 3 bit of 4 means 0 1 1. So it will do up to 7. So in the 7 means you will get the 3 bit of value like a 1 1 1. So it will count from 0 to 7, while you can count 0 to 7 using 3 bit. Okay, so if you are adding the 3 bit is nothing but your inputs. One is A and then another one is a B, and then third input is act like a carry in. Carry in is nothing but, so while you are writing, so here you are doing half adder operation. In case you are A0 B0 having 1 1 value, it means sum 0 carry 1. So while doing the binary addition, so you have to put, you must have to put some output here, and then carry output is input for another like a next full adder. So this is like a full adder, next full adder. So the one comes over here, so you have to do 3-bit addition. So that's why I'm telling a full adder is having 3 inputs. So carry out from previous full adder and then input for second full adder. So this is how full adder will working. So 3-bit adder 0 0, it will do we can give 3 inputs, we will get 2 outputs. Okay, the main inputs are A and B, and then C in, carry in. So carry in will get the output, we will get the input from previous full adder. If the first full adder means the default, we can give like a C in as a 0 or 1. While if you, for example, if you assume like this is a full adder, so we are having 2 inputs A0 B0, but we have to give the carry in for this full adder, means we can give either 0 or 1, it is our wish. Okay, we can give either 0 or 1 for carry in this first full adder. Okay, so this is how full adder will work. And then we'll see the same like a subtractor, it having some output like a difference and borrow out. So we same rule, but circuit is different. So here I'm having one NOT gate to get the power output. This is a half subtractor. So this is circuit for full subtractor. It having the 2 half subtractor and then one AR gate. So it is the circuit for full subtractor. Same like this. If you the main thing is in the subtractor, if in the case you have to borrow from neighbor bit, means you have to add the what you are borrowed from the neighbor, means you have to add to current bit. So not to override the bit, you have to just add. Like if you having 0 means 1 0, you have to add like this. You can't overwrite like a instant of in 0, you can't put 1 over here. Okay, this is the main difference. So I think it's understand. So why I'm going fast means, so today we have to see combinational logic and also sequential logics. That's why I'm going little bit fast. So okay, and then comes, I think it's clear for you, Raj Sundar, it's clear for you. And then coming to the 4-bit adder, so adder comes subtractor. So main thing is, you can see here this is one logic. So this is one circuit, so it can do addition, it can do subtraction. So how we can choose the addition subtraction means, I am having one select line. If the select line is 0, it will do addition. So it will, if my select line s equal to 1 means it will do subtraction. So how we can do means, I design circuit like this. So if you give like input, like if I'm selecting s equal 0, I will do addition. So this is my s 0. So my input of this circuit, like this part is A0 having 1, B0 having 1. Okay, both inputs are 1 1, A0 having 1, B0 having 1, here 0. So 0 means for this XOR gate, inputs are S and B0. So B0 having 1, here having 0. 1 0 is 1. So what is the output of XOR gate? Can anyone respond in chat box? So yesterday we seen, last session we are seeing gates, input and outputs, working of gates. So what is the output of this? So this XOR gate having inputs like a 0 and 1. So what is the output? Can anyone respond in chat box? So what is the output of this XOR gate? This XOR gate having 0 and 1, as it having two inputs, 0 and 1. So what is the output? So good evening sir, I kindly request please post the attendance link here, day 16 bar line scatter line. So my coordinator will post the link. So 1, yeah. So here having the 0 as output and also A0 having 1. So 1. So totally carry in also 0 here. So Narayanamurthy telling I'm correctly 1 current. So how we can say output as 1? Both inputs are different means in the XOR gate both inputs are different means we'll get the output as 1. Okay, both inputs are different, 0 1 1 0, you will get the output as 1. Due to some technical issues we can't find attendance link, so you will get, don't worry. So both input are different means you will get the output as 1. Okay, so here is a 1 and then my A0 our input is also 1 here comes over here, and then my S0, so sorry, my select line input is I'm assigning as a carry in output. Carry in means this is a C0 is a carry in, so 0 comes over here, 1 1 0. So what is the output of 1 1 0 if you add a 3 bit? So 1 1 0 1 1 0, like a 1 1 0 1 1 0, you will get the sum as 0, carry as a 1. Okay, carry as a 1. So we'll get the output like a sum as 0, carry as a 1. So 1 1 0, this here having 1, here also having 1, and then sum, selected, I'm misspelling, selection having 0. So I'm assigning the what value having selection line, I'm assigning to my carry in, so 0 comes over here. So 1 1 0 means you will get the sum 0, carry 1. Why? Because of I'm adding 3 bit, so 0 1 1, so 1 plus 1 2, sum 0, carry 1. So some S not having like a 0, and then that particular C1 having 1 value, so 0 1. So carry out is a 1 only correctly. So 0 1. So this is the input for second full adder. So this is how do this is how it will do addition operation. So if I am changing into 1 means you will get the subtraction, so it will do subtraction operation. So this is a circuit, yeah, sum 0, carry 1 correctly. Now you are telling correctly, Narayanamurthy. So thank you for your response. So this is how it works. So if you give some input for the circuit means you will get some you will get results based on your S selection. So if S equals 0, you will get the adder output, addition, it will do addition. If it is equal to 1, it will do subtraction. Okay, so this is thing. So I want to show this is a basic circuit. Okay, so and then n bit ripple carry adder. So ripple carry is nothing but cascading a full adder. So it will do the, if you are cascading, you are connecting the full adder seriously means it will do ripple carry adder. So that's a ripple carry is nothing but like a 4 adder, 5 adder, 5 bit adder. So 4 bit means 1 0 0 0 1 0 0 0. Like it will do 4 bit additions. Okay. So you can see here this is input for my first full adder. This is input for second full adder. This is input for my second nth full adder. Okay. Okay. So this is how it will work. It will do a ripple. It will do n number of bit additions. It will do 4 bit adder. We can make as a 5 bit adder. We can make as a 7 bit adder. So it will do n bit ripple carry adder. Okay. So and then the main thing is propagation delay. So what is meant by propagation delay? So propagation delay. So before going to that, I want to ask this question. So if you guys are have a knowledge in propagation delay means, you can just put some answers or some guesses in chat box. What is propagation delay? Propagation delay. So can anyone respond in chat box? If you guys really know the answer means you can respond like you can write some small words. So what will do? What is a delay? What is a propagation delay? So I think I will answer for that. So propagation delay means here the gates, mainly the propagation delay is like simple answer is gates delay. So why? Because of, assume like you having the 4 AND gate, you are connected with serially, so it depends on previous AND gate. Like a fifth AND gate is depends on fourth AND gate, fourth AND gate it depends on third AND gate. Why? Means the fifth AND gates need input, but need input from fourth AND gate. So and then fourth AND gate need input from third AND gate, but there is a delay between the gates. Why? Because of, firstly we first AND gate have to give input, give output, okay, and then only that output are assigning to my second AND gate. The output of the second AND gate is assigned to the input for my third AND gate. So each and every AND gate depends on previous AND gate, so it's like a delay. So for the fifth AND gate, it must wait for remaining previous four AND gate, like from 1 to 4 have to complete. Then only the fifth AND gate will get the input from the previous AND gate. So time required to change the output from the input. Yeah. So normally it represents how fast the digital circuits, like a logic gates, flip-flops, microprocessor respond to the change and it is inputs. So mean and max delay of logic design. Yeah, correctly. You guys are telling correctly, but main thing is gate delays. So propagation delays is nothing but gate delay. For example, so if you want to see the C5 means carry out from this fourth flip-flop, like a fourth full adder. So this is output of my fourth full adder, C5. So if you want to see output, means you must wait remaining these 3 full adder have to complete their functionalities, complete their workings. Then only you will get the output in fourth full adder. Why? Because of this fourth full adder depends on previous one. Why? Because of, so it won't get a C4, it won't get the input, like the full adder. This particular full adder needs a 3 input. One is A4, B4 and then C4. So it needs A, B and then carry in. But this carry in input is depends on previous full adder. So this full adder it having 2 outputs, sum and carry out. That particular carry out is input for next full adder. So the particular this full adder, fourth full adder must have wait for this 3 full adder have to complete. Then only it will get the input, carry in input. Okay, this is the propagation delay. So the time taken of this things, like this is a propagation delay. The delay will have more impact when more number of bits are getting added. So you can see this point, this delay will have more impact when more number of bits are getting added. Okay, so if you are designing some combinational circuit, means you must design it's like with less number of wires. If you having the n number of wires, means the propagation delay will also increase. Okay, we have to write the you have to make the design with a less number of gates. Less number of gates means you will get the less number of propagation delay, and then you can reduce the wire counts. So wire means if you are connecting the 2 gates by using wire, means that is a wire. So wire is also very important. Thank you for your immediate response. Yeah, thank you. Yeah. So and then this is the basic thing. So propagation delay is nothing but gate delay. So each and every full adder depends on previous thing. Okay, this is how we can call the propagation delay. So and then carry look ahead adder. So it is a fast adder. So previously, if this is a ripple carry of 4-bit adder, 4 full adder. So 4 full adder. So I'm counting serially. Each and every full adder depends on previous one. So if you're following this method, means you will get the delay. To neglect this, we can follow the look ahead adder, or we can also say this fast adder. So how we can design this, means, so I will show you like this. So this is a basic circuit. So each and here also we having the 4 full adder connected serially, but each and every full adder each and every full adder can capable to do the separate functionalities. Why? Because of it, these full adders won't need to depends on previous full adder, so it will do separately. So separately means, so this is one full adder, so it having a0, so three inputs, a0 b0 carry in, and then you will get the sum and then carry output. Again, this full adder also having the three inputs, but this for carry in, previously we seen like this carry in input, it is depends on previous full adder output, but here it am having some combination logic, so it will do this full adder operation over here. So what is if it will do some carry operations, so here I'm getting some two outputs, but in this combination logic I will get only one output. That one output is not like it's a carry out, so carry out of this inputs. So whatever it having, so here a0 b0 whatever it having the z1 like carry out, it will do same thing in the combinational circuit. In this block it will do same thing uh, to get the carry out of first three inputs. Okay, and then same like this only, it will do the it will do some combination logics to get the carry input for respective full adders. So for the if you want to get the carry out like a C2 means, you have to do some combination logic based on the inputs like a0 b0 z0 and then a1 b1. Okay, you can see here. So and then same like for third full adder. So by using this circuit, you can reduce the, so you can reduce the propagation delay. Okay, this is the main thing of fast adder or carry look ahead adder. So it is mostly used for fast computing. So it having some external, it having some extra gates like a extra logic, but you can reduce the time. You will get the you can get the output as soon as possible. Why? Because of it won't need another full adder have to complete the its work. So it is each and every full adder, each and every bit, it is a full 4-bit full adder, each and every bit we can get the separate output, sum and carry. It won't need to depends on previous full adder. So this is a basic thing, so I want to share. So and then propagation delay is a time it takes for a signal travel through a component from sending end to receiving end of circuit. Yeah, you are telling correctly, Annamalai. Time taken from sending end to and then receiving end. So this is a time taken. There is some time taken. That's called propagation delay. It's based on the gate delays. Okay. So thank you for your response, Annamalai. It's very good. So and then we comes to the decoder. So decoder is nothing but it will do decoding. So this is a basic truth table of decoder. Okay, it having three inputs. So I already said no. So yesterday also we seen like a sound system as example. It having only one line input, but the outputs are 5 outputs: front speaker, front right and left speaker, front center and the front center speaker, and then back left and right speaker, and then subwoofer. So it having some 6 outputs, but the input is only one input. Okay, so this is based on the decoder logic. So I'm having the 3-line to 8-line decoder. It means 3-bit input. So if I decode the 3-bit means I will get the 8 values of output, 8-bit of outputs. So how we can make the logic means with the difference of one hot one. So it means you can see that decoder is a conventional circuit that converts the binary input signals into one hot coded output. It commonly used in the digital system for address decoding, memory selection, and data routing. So one hot coded output means nothing but compare if you having the for example, this is the 2 outputs, like this is a first 3-bit input, and then you will get the output like this. So if you compare all of these output, you can notice that it will differ by only 1 bit. Okay, so it will differ by only 1 bit. So this is called one hard coded output. Okay, yeah, Narayana, you're telling correctly. So it having inputs like a it has 2 power n output lines. So n is n inputs, 2 power n outputs. So like example 3, n is equal n equal to 3. So 3 input means 2 power 3, 8. So n 3 input, 2 power 3 is 8. So you will get the 8 outputs. So okay. So main thing is one hot, one coded output. It means the output of the decoder is it differ from only 1 bit. So if you compare of these 8 outputs, like 8 outputs, so you can see here each and every row having differ from only 1 bit, not it having not differ by 2 bit. It having only 1 bit difference each and every output. You can see here. So this is a basic of a decoder. So this is if I coded like this 3 bit of 0 means I'm just assigning this is the output, and then 001 means this is the output, 010 means this is the output, and then 100 means this is the output. So this is how decoder logic will work. So and then decoder. So I think it's understand for you. Decoder is very simple only. So main thing is output is one-hearted output. One-hearted means the output of the decoder is only differ from only 1 bit. Okay. So and then let's move into this is how that circuit will work. So if you want to, if you guys are on to take picture means we can take screenshot here. This is a circuit of 3 line to 8 line decoder implementation. So if you assigning, so if you guys have some input means you can give inputs here, we'll get to some respective output. Okay. So this is a AICTE low 4-bit decoder truth table. It's like you can see here each and everything. So why this is a AICTE low? So there is a two logic in digital systems: AICTE low, AICTE high. So AICTE low means it will work based on the 0. AICTE high means it will work based on the 1. So it is AICTE low. So you can see here each and every output differ from only 1 bit, 0 here, and then 0 comes over here. So there is only one difference, only 1 bit difference in the output of decoder. Okay. So and then let's move into some logic symbol of decoder. 4-bit. So 4 input means n equal to 4, and then 2 power 4 equal to 16. So we'll get the 16 output in the decoder. So this is application of the decoder. So you can see here there is some microcontroller. Some you can assume like as a controller. It having IO ports, and then it having the 4 inputs and then 16 outputs. Okay, one output is connected to printer, one output is connected to my keyboard, and then one output is connected to my monitor, modem, scanner, disk, and then MISC. So these are my peripheral devices. I can control, so I can switch from one device to another device based on the decoder logic. So this is a binary decoder. Okay. Sir, can you provide the WhatsApp group for this batch? So I can, okay, I will make that possible. So tomorrow I will make one WhatsApp group for your guys. So I think I will inform to my coordinator. They will make it up. Okay. So and then coming to encoder. So this is the opposite of encoder. So opposite of decoder. So like a inversion operation of decoder. So an encoder is a conventional circuits that essentially perform a reverse decoder operations. So already we saw. So an encoder concept active level one of its input represent a digit such as decimal or octal digit or converts into coded output. So it means so we having some inputs. So we are converting, so we are compressing into coded output. So we are converting into some, we have some inputs, so we are converting into we are like a encoding. So coding means so compressing like the kind of thing. Okay. So this is a decimal inputs, this is a BCD output 1 2 4 8. Okay. So I will show the truth table. So this is a 4x2 input. So it will based on 2 power n input and then n outputs. So if I assume like a n is the n equal to 2, so this particular encoder will work based on the 2 power n inputs. 2 power n input means we having the n value is a 2, so 2 power 2 4 inputs, my output is 2. So n is our output, so 2 is my output. So this is how it look like this: y0, y1, y2, y3. This is my inputs. My outputs are 2 bits. So I can assume, like here you can see here 0 0 0 1. This is my first if my input like this means I will get the output like a 0 0 0 1. Output means my input look like this only: 0 0 1 0 0 1 0 0 1 0 0 means you will get the 1 1 output. So this is a the truth table for 4x2 encoder. So and then we having the 8x3 encoder. It means 8 input 3 outputs. Okay, so this is a circuit like this. This is a basic information about truth table. So encoder 4x2, 4 inputs 2 outputs. Okay, so while enter into Verilog or SystemVerilog, I will write an encoder code, and then full adder, half adder code. It will easy to understand. So you must understand this concept. So how we will getting output. So what is the difference between the input combination of inputs? You can also see here. There is also here also we having the one ordered code inputs. In decoder we are getting a one ordered code, one outputs, like a one hard coded output. Here you can see here we are having the output like a one ordered code. Here I am giving like a one ordered code as a input in encoder. We are getting output. Okay, so this is functionalities of encoder. I think you guys understand. So this is a truth table and circuit of 8:3 8x3 encoder, 8 inputs 3 outputs. Okay, so you can see here the inputs are also one ordered one. Each and every combination of inputs have difference of 1 bit. Okay, so I think till now you guys understand. So and then I will move to the MUX. Yeah, thank you. By better thoughts, your response. So and I will move to the MUX. So MUX, a multiplexer, is a device that allows digital information from several sources to be routed onto a single line of transmission. So it's like a combining, for example, telecommunications wires, our cable wires are and then encode, and then signal transmitting by using antenna. So it's like a based on the multiplexing only. So we are combining the number of inputs to a single line, so onto a single line of transmission. Okay, this is a basic functionalities of MUX. So the basic MUX has several data inputs and single output lines. So MUX having the input like a 4x1. If you take an example as a 4x1 MUX, it having the input 4 bits, and then it having another thing is a selection line. It's also important. So it has a data select inputs which permit digital data on any one of inputs to be switched to the output lines. It's like it will do switching operation based on the selection line inputs. Okay, so I will show here. So this is a 2x1 MUX. It having 2 inputs and then 1 output. Sorry, it having 3 inputs. Main 3 input is one is I0, I1, and then selection line. So selection line is useful to switch the lines. So I will show you how. I will tell you how it works. So basically it having 3 inputs, I0, I1. If you take a 2x1 MUX means it having the 2 inputs, I0, I1, and then selection line, and then 1 output, Y is my output. So this is how that circuit, that logical circuit look like this by using the logic gates. Yeah, thank you Siddharth, your response. So here we having the 2 inputs, I0, I1. So if my selection line having the 0 as an input means it will choose this line, it will select this line as an output. So whatever we are storing here, 1 bit or 2 bit or any other bit, directly it will assign to output. Okay, if my selection line is 1 means it will select this line. So whatever we are having inside my I1th line, it will give as a output. Okay, this is a basic work of MUX. It is based on the selection line. Okay, so output is depends on, so output, if you want to need output means you have to it is fully based on the selection line. It will select the line, it will select the line to get the output. Okay, this is a basic thing. So if you taken like an example, so it is a 4x1 MUX, so it having the 4 inputs and then one output and then 2 select lines. So why we have to give 4? So here only 1 bit of selection line is there, but for 4x1 we have to give the 2 bit of selection lines. We need 2 bit as a further selection line. Why we need 2 bit means, in case of you are using 1 bit selection line for 4 inputs, okay. So selection means it may be, if a single bit means it may be 0 or 1. So by using the single bit you can choose only 2 lines. You can't select from the 4 lines. But if you are having the 2 bit means you can capable to choose 4 lines. 0 0 is 1 line, 0 1 for second line, 1 0 for third line, 1 1 for fourth line. So same like that. So for that is the reason, for if you are increasing input means you can also increase the MUX selection lines. Okay. For 4 bit you need to you have to use 2 bit of selection line. For 8 bit of inputs you have to use the 3 bit of selection lines. Okay. So this is how truth will look like this. So if a selection line is 0 0 means our D length it will look like this only. So for this is a look like 4 bit input. If the S1 S0 having the input of 0 0 means it will select the D 0th line. If it is having 0 1 means it will select the D 1th line. If it is having the 1 0 means selection line having 1 0 means it will select the D second line. If it is having the 1 1 as a input of S1 S0 is, it will select the D3. Okay. Yeah, correctly. Better thoughts, you are telling correctly. So this is a basic of MUX. If you are studying the college student or if you are working for professional means you already know, I hope. So this is the basic things. So and then for 4 bit input you need 2 select lines. For 8 bit inputs you need 3 select lines. Okay. I hope this is clear for you. So and then this is the what are the values at the Q. It means it's like I am creating by using the 2x1 MUX. I'm making the 4x1 MUX. So you can see here overall it will look like the 4x1. Why? Because of 4 inputs, 3 select lines and then 1 output. It's like a 4x1 MUX, but I am creating that 4x1 MUX by using 2x1 MUX. So you guys understand? So I hope you are getting my thoughts, my points. So I am creating 4x1 MUX by using the 2x1 MUX. How we can create means this, we can create like this only. So okay. So and then the another question is, we can create the half order logic by using the MUXes also. Okay. So I think if you guys please watch this circuit. If you guys understand, you can put S in chat box. Yeah, thank you Naveen Kumar, nice for your wonderful response, nice session. So please try to understand this, plus try to observe this logic, and then tell me what you if you guys understand means just put in chat box. Yeah, yes, thank you for understand response, Narayana Murthy. So here I'm making the half order logic, but I'm using the 2x1 MUX. Okay, for example, so this is a circuit for half order logic, but I make it I make it by using the 2x1 MUX. Okay, by using 2x1 I'm making the half order logic. How we can say means, so this is my first 2x1 MUX. It having the 2 inputs I0 I1 and also I0 I1. This I'm using 2x1 MUX to make one half adder. Okay, so half adder means how many half adder means nothing but 2 input 2 output, X and Y. Okay, and then someone carry as a output. So one half adder I will get a some output, and another from one MUX I will get the some output, in another MUX I will get the carry output. Okay, carry out output. So X is my first input, Y is my first input. So I make it circuit like this. So here for this MUX I0 will get the X value, and then I1, so this is a not of x. So if you're having x equals 0 means here 0 and then 1 over comes over here, and then selection line. So selection line is based on this this MUX. So assume like a 2 input x half order having 2 input like a 0 1, x having 0, y having 1. So it will select this. Okay, 0 1 means nothing but what you will get if your input of order is 0 1, will get this output like a sum 0, sum 1 carry 1 correctly. So for half adder, so input of adder is 0 1, so you will get so I will show you the half adder truth table. Zero 1, so it means sum 1 carry 0. So let's see the how we will get the output. Here it will x0 y equal to 1, so it will select this line. So whatever it having the value, if I'm x equal to 0 means it will, so my selection line is also 0. I'm making my this MUX input selection line as I'm making as a y input. So for this selection line I'm assigning the y value to my selection line of this MUX. So my y value is 1, so it will select this I0 value. So I0 will connect with x, so whatever it having 0, so x having 1 value, x having 0, that 0 will comes over here, it will throw out from this MUX. So 0 is a MUX, so 0 comes over here. So this MUX will give the sum output. So I'm getting the 0 as output, so sum is 0. Okay, so and then it comes over here. So based on this y having the like what having been y input x0 y1. Okay, y1 means it will also choose this, so it will give the not of, so here having the x0 y1, so 1 means here already x having 1, so it will change to 1 here, so that 1 value will comes over here. So 1 0, so 1 is the sum output, another one is a carry output. Okay, so Muhammad Tawfiq, can I get certificate from this course? And also I don't attend the first 2 days. So yeah, you at least need 25 days of attendance. So already 3 days is gone, so but you can get a certificate if you attend our 30-day masterclass daily. At least you have the attendance of 25 days of attendance, then only you will get the certificate after the masterclass. I think it's clear for you. So this is how making the 2x1. You can make the half adder logic by using the 2x1. So same like this also. If you understand this means you can easily if you assume this, observe this, you can easily understand. So this is how that I think your doubt is clear, Muhammad Tawfiq. So you need at least 25 days of attendance, then only you can get the certificate after the masterclass. So and then if you guys are really interested in this masterclass, you can convert into 1 month of internship. So if you want to really purchase this internship means you will get the benefits of this in benefits like a 30 days recording session, all PPTs, source codes, and then all the resources you can downloadable, and then you will get the 4+ executive and then like exclusive projects, and then you will get the confirmation letter from IETE, and then I will get the also certificate from IETE, and then you will get the 180 days LMS course access. So and then we are providing weekly live sessions. On the time we are giving some tasks and assignments, so it will be helpful for your understanding. You can ask doubt from the live sessions. So and then you will get the academic internship report. So in the if you buy the 1 month of internship means you will get these benefits. All these 8 benefits will get at the discounted fee of just 999, just 1000. So our regular fee is 4999. This is our regular fee, but in this masterclass period we are providing internship just a discounted fee of just 999. This is a limited time period offer. So if you guys are really interested, you can buy this internship program by this registration link. So also you will get the link in chat box. Our organization will post the link in chat box. By using this you can buy our internship program. So after, if you are really interested, you can click the registration link, and also you can see this UI in the link window. So you have to fill the basic details of your of you, like your name, email, WhatsApp number, department, institutes. And then main thing is you have to choose domain as a advanced VLSI design and verification. Then only you will get the internship on that topic, otherwise you will get another domain. So we are providing a lot of domain internships, so you have to choose advanced VLSI design and verification. Okay, so and then this is a sample certificate you will get from the internship program from IETE. So we have coordinate with the IETE. So it is a central government institution for engineering and the technology telecommunications. So you can see here Institute of Electronics and Telecommunication Engineering. It's a central government institute. We have tie up with them. It's like a NIT kind of colleges. So you will get the internship certificate from like this only, from our internship program. So and then this is a thing you will get from our internship program. If you are really interested, you can get my you will get my internship program by using this link. So and then I planned to be continue with the sequential logic, but already times are getting. So I will give some intro about sequential logic. So tomorrow we'll see the sequential logic. Why? Because of it will take more time too. So at least it will take 45 minutes to explain the basics of basics of sequential logic. Why? Because of it having flip-flops, clocks. So you have to know the what is a clock frequency, so what is a time and what is a frequency. So it will take more time to explain. So I will take this session tomorrow, flip-flop and latches, sequential logics. But I will ask one simple question for tomorrow. What my question is, why do ATMs give you cash only after entering the correct pin? So this is the basic things. If you are entering into ATM, after if you enter the correct pin means then only you will get the cash, otherwise you too won't get the cash. So what is the logic behind the thing? So what is the basic logic? It is related to our digital electronics only. Can anyone respond in chat box? So what is the logic behind this question? Why do ATMs give you cash only after entering the correct pin? So are you guys understand these questions, or are you guys ready to end the session? So if you have any guesses means you can respond in chat box. So what is the basic logic behind this question? So ATM machines are giving, we are using the ATM machines to get the money. So but for that you have to give your correct pin, then only you will get the money. So can anyone respond? So what is the logic behind this question? So what is the logic behind this question? So it is related to the digital electronics only. So basically most of our process, we are doing a number of processes our day to life. Our computers will do the number of process. Our security system also doing some memory kind of things. So our data and passwords are stored in one memory. So we are using that, then only it will give the correct answer. Encoder. So encoder is kind of correct answer, but main thing is sequential logic. So sequential logic is nothing but it's like a, so sequential logic, if you're taking like example like a D flip-flop, it's like a register only. Register means memory, so it can store some data up to some clock cycles. Okay, so for example, if you taken as a D flip-flop, it will store 1 bit of data for one clock cycle, so it can store same like that. So ATM machines also work like based on the sequential logic only. So if where combinational logic means the ATM won't remember that you entered your pin correctly or not. So for that reason we have to use sequential logic. So combinational logic means it will do continuous process, it won't store the data, but sequential logic will store the data. So based on the pin only it will give money. So if the ATM machines based on the combinational logic means it will give money without your pin, so it won't store the pin. So but if your ATM machines follow the sequential logic means it will store the pin based on the pin values. If based on the correct pin only it will proceed to next step. Okay, based on the current input of your pin, based on that only it will proceed to next step means. So it's look like a sequential logic only. So why? Because of the current output is depends on present input and also previous output. So this is the basic thing of sequential logic. Okay, so current input, so the output is depends on current input as well as previous output. So it's like a memory state. So this is a basic definition of sequential circuit, sequential logic. So this is for today. I hope yeah, serial in parallel out we'll see in the upcoming classes, or else I will show the code. If I take means it will take more time to explain, it more than 1 hour. So some guys are not interested to stay in up to 1 hour. So one people only, you can see here, we can see now 36 people in the live. So that's the reason. So most of people are not that much interested if I take more than 1 hour. So that's why I wind up with within 1 hour. So see serial in parallel out, serial in serial out. So we will see in upcoming cases. So and then this is a thing I want to share. So sequential logic is the main thing is output is depends on present input and also previous output. It's like a memory set. So this is a basic definition of sequential logic. I hope you guys are getting it's clear for you. So thank you for your response. So I think this today's session is very fast. Why? Because of we have to cover all the topics. That's why I'm going fast. Why? Because of we will see the big topics in upcoming days, like verification. So SystemVerilog, assertion, coverages. There are huge topics. It's in the upcoming days. That's why I'm taking very fast. So and then please go through once sequential logic in your free time. So this is for today. Thank you for your joining. Thank you for your presence. So thank you guys. Thank you for listening. If you have any doubt from this session, you can ask now. Thank you. Yeah, thank you. Muhammad Tawfiq, thank you. So thank you guys. Thank you for listening. We'll see tomorrow with sequential logic and then another topic. So thank you guys. Thank you for listening.